You know, every single time you tap on your phone or you start your car, you're depending on this invisible battle happening on a tiny, tiny scale. Deep inside all our modern tech, there's this hidden world of super specialized materials, just fighting to keep everything working. So today, we're going to zoom in on one of the real unsung heroes of that world.
So this stuff you're looking at, it's called Anyglue E3220B. And yeah, it might look like something you'd find at a hardware store, but don't let that fool you. This is not for your weekend DIY project. Nope. This is all about creating an impenetrable shield, literal armor, for the super delicate electronic brains that power, well, pretty much everything we do.
Just think about it for a second. The circuits inside your laptop or in your car's computer, they are in a constant, brutal fight. They're dealing with crazy heat from the processors, nonstop vibrations from just moving around, and there's always this danger of stray electrical currents messing things up. Without some serious protection, they wouldn't just glitch out. They'd be toast in a matter of minutes.
Okay, so how in the world do you defend against that kind of chaos? Well, that's exactly where this stuff comes in. Let's really dig in and break down what Anyglue E3220B is and, what gives it these incredible protective powers. All right, so at its core, Anyglue E3220B is what's called an epoxy molding compound. Now, that's a pretty fancy term, but it basically means it's this high-tech material engineered for one main job, to be poured over sensitive electronics and then hardened into a solid block. It's a process called potting or encapsulating, and this gives you both physical protection and that all-important electrical insulation. So when we talk about protection, one of the first things you got to measure is hardness, right? Like how well does it hold up against being dented or scratched? For materials like this, we use something called the Shore D scale. A good way to think about it is like this. A rubber band, that is a super low shore hardness. A construction hard hat, that's got a really, really high one.
And this is where Anyglue E3220B is just completely off the charts. It cures to a hardness of over 80 on that Shore D scale. That isn't just tough, we're talking firmly in hard hat level industrial plastic territory. It is creating a literal rock-solid shell around whatever it's protecting. It's incredible.
But here's the kicker. It's not just about being hard. It also has to bond perfectly to the circuit boards and all the little components. And critically, it does this without creating a big flash of heat while it hardens, because that could totally fry the very electronics it's supposed to be protecting. And once it's set, that powerful grip holds on for dear life, even when the temperature skyrockets to 150 degrees Celsius.
So how does it do it? How does it pull off this incredible transformation from a simple liquid into this ultra-hard armor? Well, this is where we get to see some really cool chemistry in action. It's a genuine metamorphosis. Okay, it's a classic two-part system. First, you've got part A, which is the epoxy resin itself. It's this translucent, kind of thick liquid. Then you've got part B, the hardener. This one is black, and it's a much thinner liquid that acts as the catalyst. Now, on their own, they're perfectly stable, but the moment you mix them, that's when the chemical reaction kicks off.
In that recipe, it has to be absolutely perfectly precise. The magic only happens when you combine them in a specific 4-to-1 ratio by weight. Seriously, if you get this wrong, you don't get armor. You just get a goopy mess. The final material just won't have any of those incredible properties we're talking about.
Yeah, you can almost think of it like a high-stakes baking recipe, but for electronics. First step, the circuit board has to be perfectly clean. No dust, no oils, nothing. Then you mix the two parts together really, really well. This liquid armor is then carefully injected or poured over all those vital components. And after that, you just let it do its thing. At room temperature, the chemistry just takes over and does all the heavy lifting.
And this whole chemical reaction, it runs on a really specific clock. See, engineers get a working time of about 20 minutes to get that liquid exactly where it needs to be before it starts getting too thick. Then, around the 40-minute mark, it hits what's called gel time. It's not really a liquid anymore, but more of a soft solid. Then you just leave it for 24 hours, and bam! The metamorphosis is complete. It has reached its final, super hard, protective state.
All right, so once that 24-hour cure is finished, what are we left with? What do we actually have? How does this brand new, solid material really perform when we put it to the test? When the pressure's on and the heat is cranked way up? So this chart here shows its tensile strength, which is basically how well it resists being pulled apart. At room temperature, it's incredibly strong, as you can see. But what's really amazing is that second bar. Even at 150 degrees Celsius, I mean, that's well into the way too hot to touch range, it still keeps a ton of its strength. And that is absolutely crucial for making sure components don't literally get ripped off the circuit board as everything expands and contracts with the heat.
But hey, physical strength is only half the battle, right? Remember, we also need to control electricity, and for that, we measure something called volume resistivity. In simple terms, this just tells you how good a material is at being an electrical insulator. A low number means electricity can flow through it easily. A really, really high number means it stops electricity dead in its tracks.
And the value for E3220B is just, it's mind-bending. It's a 5, followed by 15 zeros. To try and put that into perspective, a great conductor like copper has a resistivity with a minus sign in front of its exponent. This number is so astronomically huge, it's basically infinity for all practical purposes. It's the ultimate electrical insulator. It's like wrapping the circuits in a perfect custom-fit rubber suit that prevents any short circuits or interference.
So, okay, it's obviously an incredible performer when it comes to strength and insulation. But, in today's world, that's not always enough. A high-performance material also has to be safe and responsible, both for the people who make our devices and, of course, for the planet.
And this material, it's definitely built for the modern world. It's totally solvent-free, which means better air quality in the factories where all our electronics are made. It's also RoHS compliant. That's a critical standard that certifies it's free of nasty heavy metals like lead and mercury. And its halogen levels are super low, so it meets all the strict safety standards for electronics. It's tough on stress, but it's gentle on the environment.
And so we come full circle back to this. You start with two pretty unassuming liquids, you put them through a perfectly controlled chemical reaction, and this is what you get. A solid, stable, custom-molded piece of armor, perfectly formed for its job.
When you get right down to it, the story of Anyglue E3220B is really a fantastic little snapshot of the entire field of materials science. It's all about taking these basic components and, through some really clever chemistry, transforming them into something truly extraordinary, a high-performance guardian for the invisible, absolutely essential technology that surrounds every single one of us.
And that really leaves us with a fascinating thought, doesn't it? This is just one material, just one of these unsung heroes. It really makes you wonder, what other invisible materials, what other amazing marvels of chemistry and engineering are hidden away inside the devices we use every single day, just quietly making it all possible?